connect the RC controller using a USB port to the laptop, and the laptop sends the PWMs to the RC controller, and then we, using the the inbuilt functionalities of the RC controller, we decide which loop is controlled by the off-board control algorithm. This is a very useful method for software validation, and it's conservative because it injects time delays that are injected due to the MATLAB. And to the best of our knowledge, this was the first time it was checked. So I just have a couple of plots that I want to show. This is a proof of concept for the outlier detection, which basically the blue dots are the measurements, the red dots are the estimates, and on the bottom we have the estimate of the velocity for these measurements. And you can see here clearly that most of the outliers, all of the outliers are detected and rejected. Here's a plot of our altitude control. This is using the MATLAB algorithm. Basically what it's trying to do is, you can see in presence of heavily noisy data, those spikes there are outliers. We're able to maintain altitude for a significant amount of time. This is a plot of our longitudinal obstacle avoidance. This is again using a forward-mounted sonar. It is trying to stay 7 feet away from a wall. You can see in presence of heavily noisy data, we are able to stay 7 feet away from the wall. Finally, I would like to show a simulation of our concept that's running, that basically what is our strategy for this competition. And here you see the MAV entering the wall environment, and it's now basically just going to follow walls. If it sees a wall on the left, it now is facing the walls, and now its strategy is going to be simply to follow this particular wall. And you can see that it is trying to follow the walls, and you can see in this very simple scenario that it's able to actually navigate the inside of the room pretty well. I think I'm running out of time, so